Just in case, my name is Alper Yegin. I'm the chair of the technical committee and vice chair of the board in LoRa Alliance and CTO of Actility. So in this half an hour, I'll talk about what LoRaWAN standards we have to help device makers and the solution makers, and how to implement and use them. If you have any questions, let's take them at the end, so I can run through this without having to skip over any slides. So these are different aspects of building and deploying devices and solutions, how to upgrade them in the field, how to integrate them with application platforms, how to provision devices, and global device activation, global device connectivity, and ensuring implementation quality and interoperability. These are the kind of things that any device maker and solution maker has been dealing with. Obviously, there are a whole lot more other things, but these are the ones that we have something to say in the LoRa Alliance. So firmware update over the air. So we have a way to upgrade, or actually we have a way to send large files to the end device in a very efficient way using physical broadcast. And those files might be a large configuration file, or it might be firmware. It can be anything. Now, given the constraints coming from the use of unlicensed ISM band, we had to define a very efficient way of achieving this. And that is done through using a physical broadcast, which is possible with LoRaWAN, and also fragmentation. Now, this obviously, we do this in a secure manner to make sure the firmware is signed, so people cannot push rogue firmware onto end devices. And also, the transmission is integrity protected, so it cannot be modified mid-air. And it also comes in as a security measure. So when you're building a device, you would like to use FUOTA for yourself in case you want to upgrade the device in the field, and also for your customers, as an insurance that if anything goes wrong in the field, they have a way to patch things up. And if we look at the architecture, there is the end device on one side, and there is the reliable multicast and the FUOTA server on the other side. And over there, transport is LoRaWAN, and in between is the network server. Now, we use the fragmentation and the multicast management, but above that, there's also a firmware management which deals with identifying the firmware file, telling the end device when to switch that with the previous firmware, reboot the device, things like that, which are very firmware specific. But what's underneath is a very generic way of fragmenting frames and using multicast to efficiently push large files to a fleet of devices all at once. And if you want to implement FUOTA, these are the technical specs you should be implementing. And this can all be found on the resource library, resource hub of LoRa Alliance. You need to have an app layer clock synchronization protocol. Well, if your device implements the link layer version 103 or later, you can instead use device time rack. Because device time rack was not available in earlier versions, we implemented an application layer equivalent of that. And TS004 fragmentation, 005 remote multicast, and if this is firmware management, then TS006. If it's just pushing a large file that you know how to deal with that, you don't need to implement TS006. And having done this implementation, what you need to do next is to do an interrupt with a FUOTA server or servers, right? Wherever you want to make it work, you should just do that interrupt. Obviously, we provide interrupt specs, so things should, in the ideal world, work, interoperate out of box. But in reality, if you have been in the networking field, you would know that you wouldn't deploy things unless you have done an interrupt. So make sure to cover that as well. And in Actility, we have a product called ThinkPark FUOTA server that deals with the FUOTA implementation and beyond. So defining devices, the multicast groups, and the files, these are all part of this product, this FUOTA server. And on top of that, we also have a smart delta scheme, meaning that when the firmware changes, instead of sending the whole new firmware, you just send the delta between the new firmware and the old one. and then tell the end device to apply this patch. So that makes the FUOTA even more efficient, and this is part of this product. And there's a concept called a campaign. When you want to update the firmware of a fleet of devices, you wouldn't just do it anytime, right? You would need to schedule a campaign to bring all these devices to listen to the network at the same time. And also, you would probably want to do it when the network is not as busy. So there's this campaign scheduling and management aspect. And then how fast you push the downlink frames, right? You don't want to push them all at once to clog the network. You want to spread them. So there's a bit of a planning. And with the ThinkPark FUOTA server, you can do all of that. Then the application payload codec APIs. Again, the payload codec is a JavaScript code that can translate binary encoded data to JSON and vice versa. We use binary for over-the-air transmission to have the most compact payload for limiting the time on air, which is a very precious resource, not only for the end device, but also for the networks to maintain capacity. But on the network side, the data needs to be translated into JSON after being interpreted according to the application, which only the application owner knows how to do that. So the JSON-based data can be stored, it can be processed, it's human-readable, machine actionable, and by defining a standard API, now the device makers can build their codecs once according to that API, and then expect it to run on any application platform that implements the same API. So we bring portability to the codecs to reduce the pain of deploying applications across multiple platforms running on different vendor implementations. So this is just an example, an uplink frame. It's a 2-byte frame that comes with metadata like the receive time and F port, running through the decode uplink functionality according to this API, produces data, which is temperature, and the value is 41. And it also produces if there were any errors and warnings. So this is just how a codec compliant with this API would run. So what do you need to do for supporting this? As a device maker or application maker, you would develop your application codec according to TS013, which is really most probably just an incremental change, because we have this API is based on the common practices in the field. It's been contributed by multiple members who already have their APIs. So most probably it's a small change to your codec to be compliant with this API. And if you are an application platform vendor, you should also implement the same API. That way you can onboard application codecs seamlessly. And in Actility, our product ThinkPark X is, one of the features of ThinkPark X is hosting and running these codecs. In our product line, there's also another name for this, a driver. So driver and the codec are two interchangeable terms. We have system codecs provided by Actility and the device makers. So when you're on an Actility ThinkPark platform in ThinkPark X, when you select a device, the system will automatically use the matching codec in its library, whether it's developed by Actility itself or the device maker. And if you bring in a device where there's no codec, or if you want to modify the codec, or if it's like a brand new device, you can also build a custom codec. There's an editor. You can start by copy-pasting an existing codec and then modify it according to your application and use it on a running system. And then let's talk about device identification. Today, people send Excels. They send in an email a Dev EUI and various device credentials, which is super non-portable, right? Now, and then there's been some vendors who use QR codes and QR readers to assist the device provisioning, but they haven't been standard. So we have standardized the QR code in LoRa Alliance, which embeds numerous identifiers like the join EUI, Dev EUI, a profile ID pointing to device profile, an owner token, which is used for claiming the device, serial number, and a checksum. So, and that goes on a sticker on the end device. And this is how it gets used. Well, first of all, this QR code is generated by the device maker and placed on the end device. So when you, as the end user holding the device, what you need to do is, instead of like trying to read the credentials on this device or go look up your email for an Excel that was sent who knows when, maybe it's in the spam, what you do is use a QR code reader to read this QR code, and that gets automatically shared with the network server for provisioning that device, onboarding that device on that platform. Now, what's happening behind the scene is the device profile is also made available from device maker to the network in a way that when the system sees the profile ID as read from the QR code, it can be matched with a device profile. Now, this device can be fully provisioned on the network server. And then the device maker behind the scene as well also provisions the credentials on the joint server, like dev EUI and app key. That's exactly why you don't see the app key on the QR code. You should not, right? A master key, a secret key shall not be on the QR code. So that's why it's not there. It's sent to the joint server. When the end device tries to join, network server knows who the joint server is because join EUI comes in through the QR code. Then the joint server knows how to authenticate the end device because it already has the app key, and the whole system clicks in without the user having to type in anything or copy paste from email. This is the QR code. So what do you need to do? Well, as a device maker, you should read the TR005, the Technical Recommendation 5 Device Identification QR codes, to see the precise format with examples and produce such QR codes and put them on the box or on the device. And as the infrastructure vendors, whether you're a network server, joint server, or application server provider, you should support QR input for device provisioning. For example, on ThinkPark, our multi-radio core network, we have two different ways of provisioning an end device. One is you just type in the values or copy paste. Two, you just click on this onboarding tag and then use the QR reader, which will directly embed the reading value into this platform, and you will see all the values are pre-populated with what is to come through the QR reading. So that's a way to quickly onboard device. Obviously, there are other schemes like bulk import or creating devices using API, etc. But for any manual operation, we leverage QR-based onboarding. Then activation. So you're a device maker. You're shipping products all around the world. Now, you know, shipping the physical device is one thing, and then how do you make the application key available to wherever that end device may land, right? Now, you also need to make the application key available to the target platform. Now, without knowing where the device will land, there's no way for you to know where to send the application key, and it just becomes a supply chain problem. So in the LoRa Alliance, the solution we present to address this problem is the separation of network server from the joint server. So joint server functionality is, a joint server is a network element that stores the app key and that can authenticate the end device and generate the session keys. Now, if you were implementing LoRaWAN, say 5 years ago, there was nothing called a joint server. It was just a network, which is today's network server. And then we built the backend API, enabling the ability to separate network server from joint server in an interoperable way, so that the device manufacturer can provision the device on a single joint server and then get that device activated on any network server around the world. So single provisioning and global activation. That is possible through this hierarchical network architecture. So then you would ask, so what should I do as a device maker? Well, first of all, you need to use a join EUI, which is also known as app EUI in the older versions of the spec, on your devices, such that it should be based on an IEEE OUI. That's another ID that's globally unique and obtained from IEEE. And that should be assigned to your organization. Either you go and license or buy that from IEEE, or you are given that from someone else who owns a larger chunk of IEEE OUI, okay? So you have to make sure however you're generating joint UI should be based on a global unique ID. It should not be random. It should not be arbitrary, which we see that a lot, and that makes the whole system collapse. Well, not the whole system collapse, but you get yourself into trouble. Your system collapses. So just make sure you have this globally unique join UI, and then make sure it points to a globally reachable join server, okay? Now, that join server may be yours as a device maker, and you may be running that, or you may rely on a third-party join server and park your join UI on that server and then store your app keys on that server. So in either way, it should be a globally reachable join server. Then that's how you ensure your device can activate all around the world. So, so what do we do on that front in Actility is we have our globally available join server called ThinkPark Activation, and it's connected to the LoRaWAN backbone that we are operating over ThinkPark Exchange. So the networks you see on this picture are all on the backbone, meaning that any device on any of these networks could be activated through ThinkPark Activation once that device is provisioned on this platform. So this platform supports QR codes. It supports an HSM, hardware security module. For the high-end security applications, we have the ability to store the keys not in software, but in a dedicated appliance that's purpose-built for safeguarding crypto keys and procedures. And it also supports secure elements. So you could have devices built using secure elements from ST, Microchip, Trust Objects, and IDEMIA. And both secure elements and HSMs are supported on ThinkPark Activation as well. Now, one can use ThinkPark Activation through ThinkPark Exchange-based backbone, and also it can also be used in a direct mode on customer premise as well. So we have different forms of deploying ThinkPark Activation. And then you would wonder, okay, I can activate, but now I also like to bundle connectives, right? I just don't want to sell a device. I want to sell a connected device so that my customer shouldn't have to get the device from me and then shop around for connectivity, which is a hassle. A lot of customers don't even know how to do that, and it's also a hassle for the network providers as well. So if you could bundle connectivity, that would be the ideal case. So, so this is the scenario. You are a solution maker. If you want to bundle connectivity, then you need to have your own core network that runs the so-called home network server. So in addition to running your application server, you front that with a network server that is in roaming agreement with multiple networks, okay? Through that, your devices could be in network 1, network 2, those blue circles coverage, and wherever they are, they can get activated and send uplink frames and receive downlink frames, and all these frames will come to the home network server and made available to your application server. So even though having a core network sounds like something like too complicated, it's really not so. It's just a system running alongside your application server. It can run in the cloud. It can run on customer premise. It can even be embedded inside a gateway. So there are different form factors for that one as well. So, so how do you achieve that? Well, you need to have a core network, which is a combination of network server and application server. Most probably you already have an application server if you are providing this as a service, right? Now you bundle a network server with that. And then you need to set up roaming with your own choices of public, private, and community networks. Wherever your devices needs to go, then you need to identify a partner to set up roaming. Now that roaming agreement could be done on a peer-to-peer fashion. You can go around and set up those roaming, or you can leverage roaming hubs so that you have a single point of integration, and through which you can also leverage various reseller agreements, so you wouldn't have to have a commercial agreement with every operator one at a time. So again, going back to ThinkPark Exchange, this is exactly what the solution providers in this red rectangle are doing, like Birds, Air Liquide. Schneider, Farmode, Epic. They've got devices that are bundled with connectivity. And for bundling connectivity, they have roaming agreements with various network operators, public and private, and also community on this backbone. And through that, they're able to tell their customers, just buy this device and power it on. It's going to connect automatically. Like Schneider Electric, they've got electric cabinets in multiple countries in Europe, like France, Switzerland, Netherlands, and they're all connected to the public networks through a public to private roaming that's been established through ThinkPark Exchange. And finally, you want to ensure quality. You want to make sure your device does really work the way it's been implemented. Two things you need to do. One is certification. You need to get certification through LoRa Alliance. You can do a pretest of your device using LCTT, and then you would, once you clear that pretest on your own site without having to come to the Alliance, then you come to the Alliance and select an authorized test lab and get your device tested. And once you pass the certification procedures that are run in the authorized test houses, you have your certification, and that is the validation of the quality of your implementation. But then you still need to do an interop, right? You want to make sure your device does work with the partner network servers wherever they get activated. For that, you need to run interop sessions. So you need to identify who the network server providers are in the target networks you will be deploying, and you need to do interop sessions with every one of them. So if you are going to activate your device in a ThinkPark-powered network, for that we have a ThinkPark interop tool that's available through ThinkPark community. It's free of charge. Using the community platform is free of charge, and so is the interop tool. And here's the link to find more about that. And you run your session, and once your session is successful, now you're holding a device that is compliant with this standard because it has a certification, and that's for sure to work properly because it has cleared the interop. Now you can freely be shipping that device all around the world. And final slide, if you want to know more about all these technologies, visit the resource library. You would find the standard specs, technical recommendations, FAQs, and webinars. And if you want to try ThinkPark network server free of charge for your non-commercial use, please visit community.thinkpark.org. You will have access to all the technologies that I have presented on this slide, on these slides. With that, thank you very much. Now, if there are any questions, I can take them.
I had a question about the join EUI. You said that it should point to a globally reachable join server. That implies there's some global lookup table or name service that the entire industry has agreed to use. What is that? Where does one find that?
Right. So the join EUI, if you follow the IEEE UI allocation, it's globally unique. But then you need to map that to a URL, right? Now, today you can do it either manually, knowing that this join EUI matches this URL. For the time being, the number of global join servers are very few. So it's a small table for the time being. And the second way to deal with that is if you are using a roaming hub, then the roaming hub knows how to find those join servers. So say you have a network server that's connected to the hub. All it does is when it receives a join request, it'll forward that to the hub. And hub has that table already, that global table. It knows how to forward that. And the third thing, which is not fully deployed yet, in the backend specification, we have a DNS-based way of translating a join EUI to a URL. It's in the spec, but it's not globally operational yet, because for that, we need to set up a DNS server that does that translation for anyone. So it's work in progress, and for the time being, for the limited number of join servers, this is manageable. As we move forward, the DNS will kick in as well. Whether you're using DNS or a hub, you will find your way around.
But this short table that you said exists, where do we find that table?
Okay, good question. If you can send me an email, I can send you that table.
Okay.
But you know what, that's a very good point. We will, I'll take that as an action item for the TC to generate that table and make it available.
Thank you.
I'll remember that, do that. Thank you. All right, anything else? All right, if nothing else, then there's one more question, yes?
Why isn't it certification for the network server? I mean, if we need to certify our end devices, why not certify the network servers? We know that it's working together.
Yes, yes, good question. Why not certify the network servers? So we have started certifying the end device because that's where we have the need the most, given that there are like, thousands and thousands of device makers with variable background. So that's where we have more harmonization to do for quality front. That's why we have started from the end devices. But then we also have a plan to do certification on the network server, joint server, application server, gateway, so on and so forth. Those are all roadmap items. It's just that we are not, as the Alliance, we don't have the resources to do all at once. If you go to certification committee, you will hear their plan to certify these different elements. And it's not only certifying a network server, but it's certifying network server for a given protocol, right? You would need to certify a network server for the link layer spec. And also, if you are using roaming, you would need to certify it for the roaming, maybe for the FUOTA, so on and so forth. There's even more granularity of certification for the end device. So these are all planned roadmap items, but they're not available today for the resource planning reasons. Help is on its way. Yes?
About the geolocation you mentioned earlier, it's time difference of arrival based, suggests that the gateways have to be clock synchronized. Is it typically done with NTP or GPS? Okay.
GPS, yeah,
Okay.
yeah. The gateways needs to have a GPS receiver. Now, yes, that's how exactly. Yeah, for that, they need to have a GPS receiver. They get clock synchronized, and then through beacons, they also synchronize the end. Well, okay, that's Class B, never mind that. Yes, that's how.
Okay.
Yep. Anything else? All right, then. Thank you very much for listening.